Physical Science. This is Mr. B, and we're going to wrap up Chapter 5 today with our last 3, maybe 4 representative groups of the periodic table. And these ones are kind of the more, famous ones, for the lack of a better word, that really contain some of our more prevalent elements that we really care about. So our first one that we're going to take a look at is the nitrogen family, and this is group 5A, and it contains 2 nonmetals, nitrogen and phosphorus, 2 metalloids, arsenic and antimony, and 1 metal, bismuth. And it includes elements with a wide range of physical properties, so there's not a lot of consistency in the properties in this group. Nitrogen is a nonmetal gas, phosphorus is a solid nonmetal, and bismuth is a dense metal. And all of these elements in group 5A have 5 valence electrons. So when air is cooled, the oxygen condenses before the nitrogen because nitrogen has a lower boiling point than oxygen, and much of the nitrogen obtained from air is used to produce fertilizers. So nitrogen, if you did not know, is the most abundant element that we have in the Earth's atmosphere, and so one way that we can kind of harness this nitrogen for use is actually obtaining it from the air and using it to produce fertilizers, because like almost 70% of the air that we breathe in is actually made up of nitrogen. So it is extremely important, and one of the things that humans do with it is they make fertilizers. And besides nitrogen, fertilizers often contain phosphorus, which is another nonmetal that is found in the nitrogen family in group 5A. And so the number on the bags of fertilizer are from left to right, the relative amounts of nitrogen, phosphorus, and potassium. So right here, you can see a 5-6-5 blend of nitrogen, phosphorus, and then potassium, which is and all the way over in group 1A. So that is one of the most important uses, and this is probably an extremely important use for people in our area, because we have a lot of farmers that use a lot of different fertilizers, and they probably depend heavily on this nitrogen and phosphorus combination here to make sure they have solid crops each year. So that nitrogen family probably plays more of a role in your life than you could ever possibly imagine. So our next group is the oxygen family, and you're going to guess what probably the first one in group 6A is oxygen. It contains 3 nonmetals, which oxygen being 1, sulfur and selenium. There's 2 metalloids, tellurium and polonium. And all the elements in group 6A, again, I'm sure hopefully you can guess by now, have 6 valence electrons. And oxygen is important because it is actually the most abundant element in Earth's crust. So remember we said that silicon is the second most abundant element in Earth's crust, and then aluminum was the most abundant metal in Earth's crust. So a lot of different kind of elements have been thrown around there. Just make sure we get it clear that oxygen is in fact the actual most abundant. There's more oxygen than any other element in our crust, and that is a good thing because complex forms of life need oxygen to stay alive, because oxygen is used to release the energy stored in food. And we're going to see there's this process known as cellular respiration, which you will be learning about in biology next year as well, that oxygen is basically the driving force behind. Without oxygen, we wouldn't be able to actually take the food that we eat, and our body wouldn't be able to convert it into a form that is actually usable energy. So oxygen is extremely important. And then ozone is another form of the element oxygen, and at upper levels of the atmosphere, ozone absorbs harmful radiation emitted by the sun. And there was a big scare probably 20 to 30, if not even 40 years ago, about the ozone layer being depleted, which it actually was. But now there's actually been evidence that through the way that humans have been changing a little bit, that the ozone is in fact starting to repair itself a little. So if we keep being responsible, our ozone layer will not actually have a giant hole in it, and we will be able to hopefully build that up and help keep out some of the harmful radiation caused by the sun. So oxygen, very important element, and again it is the top of the oxygen family, which remember is group 6A, so it has 6 valence electrons. And then another member of this group, sulfur, it was one of the first elements ever to be discovered because it's found in large natural deposits. So there's just big batches of sulfur, again, kind of all clustered together, and that made it one of the first elements to ever be discovered. So I believe that's it for the oxygen family. Again, we're going to keep moving along here. Again, we'll dive more in depth to these in class to actually take a look at the characteristics of these different groups. Our next one is the halogens, and the elements in group 7A are called the halogens, and each halogen has 7 valence electrons, and at room temperature, chlorine is a gas, bromine is a liquid, and iodine is a solid. So we have a lot of different characteristics just within this halogen group, so a lot of variety here. And despite their differences, the halogens actually do have similar chemical properties. So even though we have one that's a gas, one that's a liquid, and one that's a solid at room temperature, and if you look here we have another gas and another solid, so we have 2, 1, and 2 at room temperature, their physical characteristics and their chemical properties are actually very similar. I'm sorry, not their physical characteristics. Physical characteristics, very different. Their chemical properties are what is similar. So even though they have the different physical characteristics, they're going to have very similar chemical properties. All halogens react easily with most metals. And this photo shows chlorine actually reacting with steel wool, and that is a very violent reaction that we have going on right there. So that is the halogens, and so now our last one, our group known as the noble gases, and they are found in group 8A, and this is all the way over to the far right. So helium has 2 valence electrons, and each of the other noble gases is going to have 8 valence electrons. So I would make sure you wrote this down. This is going to be a big key here. And we can't say that all the elements in group 8A have 8 valence electrons. Helium is the one exception. And the noble gases are colorless and odorless, and they're extremely unreactive. And this might throw you for a loop based off this next slide that I'm going to show you. But when we say that they're colorless and odorless and extremely unreactive, that means they're found in abundance in nature, or they're found in gas form. They're not going to react very well. And colorless is when they are not really altered. So if we just saw helium floating around, we're not going to be able to see it. It has no color. We're not going to be able to smell it. However, something very interesting about this group is that when you pass an electric current through a noble gas, they emit different colors. So you might have heard of neon lights, but there's actually helium lights, neon lights, argon lights, krypton lights, and xenon lights. So helium is actually going to emit the color pink, neon will emit an orange-reddish color, argon will emit a lavender color, and krypton emits white, and xenon emits blue. So you might have seen signs like this before. People usually just call them neon lights, but there's probably a better term would be a noble gas light, because if there's different colors besides the orangish red, that means there's a different element, a different noble gas present there. So I think that's something interesting about this group. So I believe that is it for chapter 5, and again we're going to dive more in depth, talking more about some of these elements as we go here, but this is just an introduction to make sure we're aware of what's going on. So make sure if you have any questions, you let me know.